All right, chapter 12, section 1, sample space and probability. This is like the intro to the chapter. Probability experiment, an action or trial that has varied results. Okay, what is the probability of something? You're just finding the result of something. Outcome, a possible result of an experiment. So what is my outcome of the probability? A couple things to know. When you roll a die, there are 6 possible outcomes because there's 6 total sides. If you flip a coin, there's 2 possible outcomes. There are 2 total sides of a coin, heads and tails. Something else that you should know, if it specifies the number of sides on your die, please use that number. So yes, you can have a 10-sided die. Okay, you could have a dice with 10 sides. If it does not say it's a 10-sided die or it's a 10-sided dice, you're using 6 sides regardless. Okay, always use 6 sides unless they specify. Event, an outcome or collection of outcomes. So rolling an even number, what's the probability of me rolling an even number? What's the probability of me pulling a red card out of my different colored cards? Okay, that's my event, that's the outcome. Sample space is the set of all possible outcomes. How many total possible outcomes can I have? And we're going to be seeing that as we go through here. All right, looking at this example, it says you flip a coin twice. How many possible outcomes are in the sample space? So that's the first question, and they want me to list all possible outcomes. Keep in mind, you're flipping a coin. How many times are you flipping the coin? Twice. How many sides does a coin have? 2. So think of it as this way, please. My coin flip, I have 2 sides, and then I'm flipping a coin again. I'm going to also get 2 sides. So how many total possible outcomes? I'm multiplying them. I'm going to end up with 4 possible outcomes. Now, what are my possible outcomes? What are they? What can they be? Pay attention to how I'm writing it. My first coin, I flip it and I'm going to get heads and tails. Keep in mind, for my second coin, I can get heads and tails using my first flip. I can also get heads and tails using my second flip. So this is my branches. This is the outcomes. There were a total of 4 possible outcomes. What are my outcomes? I could either get heads to heads, heads to tails, tails to heads, and tails to tails. Okay, so those are my possible outcomes of me flipping a coin twice. I could get any one of those patterns per se. All right, now let's just say they asked, okay, what's the probability of getting tails and heads? How many total outcomes did I have? How many possible outcomes? I have 4. And out of those 4, how many are tails to heads? 1. Okay, heads to tails is different than tails to heads, so do not get those mixed up. I can flip my coin the first time and get heads, and then if I flip it again, I'm going to get tails. It's different than me flipping it the first time and getting tails, and flipping it a second time and getting heads. All right, looking at the second question, it says, you flip a coin and roll a number cube. How many possible outcomes are in the sample space? List the possible outcomes. So we need to find the total amount of possible outcomes. So finding the number first and then listing the possibilities. I'm looking at it and I have a coin. How many sides does a coin have? 2. And what about a cube? 6. So multiplying them. How many possible outcomes can I have? 12. Now let me go ahead and list my 12 outcomes. I have my coin, which is heads and tails. And then I'm gonna have my cube, and it has 6 sides. Keep in mind it's 6 sides for each. So looking at it, I'm gonna have all of these. So labeling them, I could have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, and I could have tails 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Okay, I could roll on any one of those. I could roll my dice and flip my coin, and I could get any one of those. Now, let's just say they asked, okay, what is the probability of you getting heads and 5? How many sample space do I have? How many total did I have? 12. And out of those 12, how many are heads and 5? 1. All right, probability of an event. It's the chance or likelihood that the event will occur. When I'm talking about an event, or when you're given what's the probability of an event happening, you're always looking at numbers between 0 and 1, or you could think of it as 0 to 100%. When they're asking you this, it could be written as a fraction, decimal, or a percent. Okay, keep that in mind on your homework. It could ask you for either one of those, so please pay attention to what it's asking. Okay, so looking at this, probability of an event A is written as PA, whatever the event is. Even cards, probability of even cards, probability of it raining. Okay, that's my event. So just so you have it, okay, we should kind of know these. Okay, 0 is just 0%. 0.25, you cannot write it as 25 over 100 for your fraction. It has to be in simplest form. So this one's an easy one. It's just going to be 1/4. And it also could be written as 25%. This one's going to be 50%. And this is, again, not 50 over 100. It's going to be 1/2. This is 75%, and again, it's not 75 over 100. It's going to be 3/4. And then this one could just be written as 100%. Okay, so just so we have those and clarify those. So for example, if it asks me, what is the probability of landing on heads?
Is Michaela Webster class?
Looking at heads on my coin, there's 1 head out of 2. That would give me a 50% or 0.5. Okay, either one of those, again, depending on what they're asking for on your homework. All right, theoretical probability. Theoretical probability is when the outcomes are all equal. Okay, they're all equally likely to occur. So for example, if I flipped a coin 10 times, what's the probability of it landing on heads? What's the probability of landing on tails? 50%. Okay, it's going to half land on heads, half land on tails. There's 2 sides. So, looking at this, theoretical probability equals the number of favorable outcomes to the total number of outcomes. So again, let's just say we're flipping a coin. The probability of it landing on heads is 1 out of total number of outcomes. There are 2 outcomes here, heads and tails. That's it. So this one would be 50% or 0.5. Let's say, what's the probability of me rolling a dice and it landing on 4? There's only 1 4 on my die. There are 6 total sides. And this could be written as 0.16. Keep in mind that's repeating. That 6 is repeating. or 16.6% where this is repeating. If you get a repeating decimal for your percent, it will sometimes ask, well, you can't do that on your homework. So you'd have to write it as a mixed number. Does anybody know what 6 repeating is as a fraction? 0.6 repeating? If you don't know, all you have to do is divide. Okay? So you guys did percent over 100, or is over of equals percent over 100. You could think of it that way. I don't know my percent over 100. You could cross multiply 6x equals 100. Divide it by 6. This goes in once. You're going to get 4. Bring your 0 down 6 times. And you're going to get 4 left over. So 16 and 4 over 6. But you have to simplify it. Again, like I said, it has to be simplified. 16 and 4 over 6 would be what simplified? What's 4 over 6 simplified, guys? 2/3%. Your homework could also ask you, round to the whole number. The whole percent will be 17%. Okay, that's the whole number. All right, another example for theoretical probability is, let's say, what's the probability of me rolling a dice on an even number? How many even numbers are on a dice? 3. So I have 3 out of 6, which would again give me 1/2, 50%, or 0.5. All right, looking at example number 2, it says you toss a coin and roll a cube. What is the probability that the coin shows heads and the number cube shows 5? So we kind of did this one already, but it's asking me for something else. So what is my total outcomes? Okay, what is my total? How many total outcomes can I have? What's my total sample? What's my sample space? I have, how many sides of a coin do I have? 2. What about a cube? 6. So my total outcomes is going to be 12. Okay, that's my possible outcomes. So right now, what am I looking for? I'm looking for the probability of it landing on heads and a 5. I'm going to have 12 is my total. And then out of that total, out of my sample, how many could be heads with a 5? So again, I'm going to write it even though we kind of know. I have heads 1, heads 2, heads 3, heads 4, heads 5, and heads 6. And then I also have tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Out of all of my samples, how many of them are heads 5? 1. So my ratio is going to be 1 out of 12. Keep in mind, you have to understand how to change this to a decimal. What would this be as a decimal? Go ahead and divide it. What would it be? 1 out of 12. Good, I'm going to get 0.083 repeating as my decimal. As my percent, I'm going to get 8.3 repeating percent, but again, I don't want that bar notation there. I don't want a repeating decimal. So 0.33333 repeating is just going to be 8 8.33%. And if they ask me to round to the nearest whole percent, it's just going to be 8%. Looking at the next question, it says, what is the probability that a student chooses a t-shirt with a gold emblem? So looking at it, I need to determine how many of these t-shirts have a gold emblem. 16. Okay, that's what I have up top. How many total shirts did I have? I'm going to have to add these. What's 16 plus 14? It's going to give me 30. Yes, this is correct, but it must be simplified. What's 16 over 30 simplified? Simplify it using 2. If you simplify it using 2, you're going to have 8 over 15. And again, they could ask you this as a decimal, which is 0.53 repeating, or they could ask you this as a percent, which is 53 repeating percent. And again, it's a repeating decimal, so it's going to be 53.3 or 53 and a third, not 0.3. And rounding to the nearest whole, it's just going to be 53%. All right, it's asking probability of the complement of an event. Okay, again, when we're giving the probability of an event, it's looked at as 1, 0 to 1, or you could think of it as a percent, which is 0 to 100%. If you're looking at it as a percent, your probability has to be in percent form. If you're looking at it as 0 to 1, it should be a decimal. Okay, so looking at this question, they're giving me the information and they're telling me that the probability of A is 0.45. So I'm going to take that 1 and I'm subtracting 0.45, which would give me 0.55 as my answer. Again, another way you can do this, if they're telling you the probability of A is 45%, you could subtract 100 minus 45, and that'll still give you the complement of A as 55%. Okay, so it's the same thing, the decimal and the percent is the same. But again, complement of events, you're subtracting by either 1 using a decimal or 100 using the percent. So giving you an example, let's say if there's a 30% chance of rain. What is the probability that it will not rain? 70%. You just have to subtract it from 100. So 70% that it will not rain. Okay, so you're always subtracting. It's the complement. All right, geometric probability. For geometric probability, you're going to have to calculate something. You're going to have to find something. So you're using the ratio of either the lengths, the areas, or the volume. For this one, we're going to use the area. It says you throw a dart at the board shown. The dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? So for this, we have to solve for both to figure out which one is more likely or which one's less likely. So first thing, I know I'm going to be using area. Okay, so looking at it, I'm going to go ahead and first find the probability of me getting the 10 points. So looking at my 10 points, I have to find my area of my 10-point section. So area of 10 points, which is my red section, over the total area. Okay, can I find my total area? Yes, I can. I have a square. What's the formula for area of a square? Does anybody remember? What's the formula for area of a square? Length times width, base times height, however you want to think about it. I know that because this is 3, this is 3, this is 3, which makes my radius of my square 9. And my diameter is going to be 18. So for total area, all I'm doing is multiplying 18 times 18. And then how do I find the area of a square? So looking at my red, how would I find the area of that red square? What's the formula for area of a square? Area is always squared. So I'm going to get pi times my radius, which was 3 for that little square, squared. So solving it, I'm going to get 9 pi over 18 times 18 is 324. And I have to solve. Keep in mind I want to change it to a decimal. These are going to simplify. I'm going to end up with pi over 36. Changing that to a decimal on my calculator is 0.087266. I'm going to leave it like that. And now I'm going to go ahead and do the probability of me landing on 0 points. Pay attention to how I'm finding my 0 points, because a lot of students get confused on this. We kind of did this last chapter. I need to find the area of the outside, which is the blue part. And then I have the total, which we already found. So looking at my blue part, how would I find the area of my blue part? What do I have to do? Yeah.
The total minus the area of the yellow, blue, and red circle and line.
Okay, so I need to take the total area, which we know how to find the total area. You're squaring your sides. So I'm going to take 18 squared minus the area of this entire circle. I'll highlight it. This entire thing, okay? The entire big circle, regardless of the green, regardless of the pink. It's just the entire big circle. So how do I find area again? It's pi times radius squared. And what's my radius for my big circle? 9. Good. And I'm squaring it over 18 squared. So solving this, do not cancel out those 18 squareds. I'm going to end up getting 324 minus 81 pi over 324, and I'm solving this. I'm going to end up with 69.53099 over 324, and then dividing that, you could just use what you had in your calculator. Dividing it, you're going to get 0.21460. So looking at what I have, looking at my outcomes, this for 10 points, this for 0 points, which one am I more likely to land on? 0 would be my answer, because it's the bigger number. All right, experimental probability is exactly what it means. I have to do an experiment first. I have to work on trials. Going back to theoretical, it's in theory. It's going to happen equally, but that's not always the fact. That's not always the case. So experimental probability is based on repeated trials. So me flipping a coin multiple times, will it always equally land on heads? The equal amount of times it's going to land on tails? Most likely it will not. Okay, so experimental probability is based on your trials. The number of trials is the number of times the experiment is performed. So when I'm looking at this, it's the number of successes over the number of trials. So giving you an example, flipping a coin like I said before. If I were to flip a coin 10 times, so I'm flipping my coin 10 times, and let's say I get heads 3 times and tails 7. what's the probability of me landing on heads? How many times did I perform the trial? 10 times. And out of those 10 times, how many times did I land on heads? 3. So I could either write it as 10 over 3. I could also write it as 30%. Or I could write it as 0.3 as a decimal. Okay, so again, experimental probability is using the number of trials. Now we're going to go ahead and compare it to theoretical probability. We went over theoretical probability, so let's go ahead and use it for this question. It says, each section of the spinner shown has the same area. So your blue one has the same area as your green one, and your yellow one, and your red one. The table shows the results for which experiment? Well, key thing here is they told us how many times they spun it. Or you would have to add up all the numbers, okay? If they didn't tell you they spun it 20 times, you'd have to add them. But looking at the question they're asking, for which color is the experimental probability of stopping the color the same as the theoretical probabilities? They want to find which one has the same when you're using experimental or theoretical. So let's go ahead and do experimental first. Looking at it, how many total times was the spinner spun? 20 times. How many times did it land on red? 5. I have to simplify that. What would this be as a simplified fraction? Good. Looking at the next one, my green, how many times did I spin it? 20, I landed on green 9 times. I cannot simplify that. Looking at blue, again, I spun it 20 times. I landed on 3 times. I can't simplify that. And then yellow, it was spun 20 times, and it landed on yellow 3 times. That's experimental probability. Theoretical probabilities, how many outcomes can I have? 4. How many times can it land on red? 1 out of 4. How many times is it going to land on green? Let me get a different green. 1 out of 4. It's going to land on blue 1 out of 4 times, and it's going to land on yellow 1 out of 4. Which one has the same probability? My red one. Okay, so understand the difference between experimental and theoretical.